Hello and welcome back to Mthpt 103. Today we're going to talk about exponents, and then I'm going to take a short break and then we'll come back and we'll do roots. So in front of you have an example of what an exponent looks like. The exponent is the 3 that they're showing with the exponent arrow. The base is what we call the 4, or the number that we are multiplying that many times. So as you can see by the example, the base is the number being multiplied. The exponent is how many times we multiply it. So the whole idea behind exponents is that it's a shortcut to multiplication. Instead of having to plug into the calculator 4 times 4 times 4, we can go 4, hit the exponent button, and then hit the 3. So using these on our calculator, there's 2 buttons that you might be using depending on your calculator. So let me turn my pen on real quick. So one of those buttons looks like this, and this is called a caret. And so on your calculator you want to look for that, and that means power or exponent. The other option is a button that looks like x to the y. In both cases you'll put in the 4, then you'll hit either the x to the y button or the caret, then you'll hit the 3, and then you'll hit answer or equals, depending on your calculator. So if we go ahead and do that, 4 to the 3rd, turn my calculator on real quick. So 4, hit your button, and 3. So I have 64. So 4 times 4 is 16, 16 times 4 is 64. Now you can tell it definitely on number 2, you wouldn't want to plug in 8 times 8 times 8 times 8 6 times. It'd be much quicker to do the power or the exponent. So whatever you have, do 8 to the 6th power, and you get a very nice large number, 262,144. But that is the same answer you would get if you did take the time to put in 8 times 8 times 8 times 8 times 8 times 8. Okay, so now there are some rules, because we won't always be working with actual numbers. Sometimes we'll be working with variables. And so there are some rules that help us to simplify our expressions. So our multiplication rule, the big thing here is that the a's, which are the bases, are the same. You can't do this rule without it. And then you just take the 2 exponents, the x and the y, and you add them together. Next rule is the division rule. Again, we have to have like bases, but then instead of adding like we did with multiplying, we're going to do the opposite. Since division is the opposite of multiplication, we're going to do the opposite of addition, and we're going to subtract the exponents. On the next one, we have 1 base instead of 2. It's to the x power, and then the whole expression is to the y power. So when this occurs, we take these 2 exponents and we multiply them together. The key on the power of a product rule is that we have 2 terms inside of here, inside the parentheses, and they each get the power of the x. Likewise, that happens if we're doing a fraction or dividing. Each of the a and the b get the power of the x. The 0 exponent rule says that anything to the 0 power is 1. It's the letter a, it's the letter f, it could be a number, so like 6 to the 0 is still 1. It could be a car to the 0 is 1. It doesn't matter. And then the negative exponent rule says a to the negative x is equal to 1 over x. It's one of those mathematical things. It's a faux pas per se to say that we have a negative exponent. It's not allowed. And so what we do instead, we move it to the denominator. Now, if by chance you happen to have a negative already in the denominator, you would do the opposite, and it would become a to the x, which would be over 1, but we don't necessarily need that. So if it's by itself or over 1, you move it to the denominator. If it's already in the denominator, you move it to the numerator. So now we're going to apply these rules, sometimes with numbers, sometimes with letters. So the first one, now you could plug in 4 to the 6 times 4 to the 3rd into your calculator. So if we were to do that, 4 to the 6 times 4 to the 3rd, just to practice. Four to the 6th times 4 to the 3rd. I got 200 62,144. Now, just to practice on these ideas of these numbers, since we are multiplying, we are going to add exponents. So it's 6 plus 3. 6 plus 3 is 9. So if we plugged in 4 to the 9th, we should get the exact same answer. So try it. 4 to the 9th. I got 262,144. So with numbers, you could do it this way. It really doesn't take that much longer. But to get into the practice of working with the exponents, we're going to do the 6 plus 3 and get 9. And we can just prove that we get the same answer. Now on the next one, we have three things that we're multiplying. It doesn't matter. They're all base x. Remember, if nothing is occurring, that is an invisible 1 there. So we're going to go ahead and add exponents. So it's a 4 plus a 5 plus a 1. 4 plus 5 is 9, 9 plus 1 is 10. So x to the 4th plus x to the 5th times x to the 1st is the same as x to the 10th. Now this is to a power rule. The power rule says that with the exponents we multiply them. So we're going to do 5 times 6 in this case. 5 times 6 is 30. On this one we have where we have individual numbers inside. Remember, they each get the exponent. So this is 3 to the 4th times 6 to the 4th. Now if I truly just had to solve this, there's nothing wrong with just going 6 times 3 is 18 and do 18 to the 4th. Either way, if we plug in 18 to the 4th power, take a second and do that, we get 104,976. If I go ahead and try the other way, 3 to the 4th power times 6 to the 4th power, I get 104,976. So the numbers are nice because you can check that the rule truly does apply. Now in the 7th one again, we're going to give each of these terms that power, but notice this time we have another power besides just what's not there. So let's go ahead and put the 1 there. So we're going to kind of combine this idea of to a power here. We're going to do it with both terms. So I have a 1, and since it's to a power, I multiply it, and then I have y to the 3rd to the power, so I multiply by the 6 again. 1 times 6 is 6, 3 times 6 is 18. So there's our final answer. Now it doesn't matter if it's multiplying or if it's dividing, they still each get the power. So on this one we would have 3 to the 5th over 7 to the 5th. So if I put that in, 3 to the 5th power is 243. 7 to the 5th power, nice large number, 16,807. Now, especially if you have a math phobia as far as the fractions go, this is very nice because we can do them individually, put this in, get this number, put 7 to the 5th in, get this number, and be done. Whereas putting 3/7 sometimes into the calculator can be a pain if you don't have a fraction key. Okay, number 9. As we move on to number 9, notice that we're dividing. When we divide the rule up above, we slide back up for a minute. We're dividing, so when we divide, we subtract. And you can have that chart around while you're doing your assignment. It would be good to have it sitting next to you so you can refer back to it. So since I'm dividing, that's what a fraction bar means, we're going to do 10 minus 5. 10 minus 5 is 5. Now when I go to do this one with here, what we're going to notice is I'm going to still subtract because I'm still dividing. I get 4 minus 8. 4 minus 8 is negative 4. Can't have negative exponents, so we're kind of combining a few rules. So this is essentially over 1, so we're going to flip it. It's going to become 1 over 7 to the 4th. Now I want to kind of show you for a second with these two division problems what's happening. So this top one on number 9 says that you have 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The bottom one says we have 5. 1, 2, 3, 4, 5. I'm going to switch colors here real quick so I can show you. What happens if you have something over itself, it cancels. And it cancels, and it cancels, and it cancels, and it cancels. So what you notice is we have now 5 x's left. So that's how I got that answer. Now if I do similar on number 10, the top has 4 7s. 1, 2, 3, 4. The bottom has 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to switch back to my other color. Again, I'm canceling. If I have it on top and bottom, it cancels. Notice that on the denominator, I have 1, 2, 3, 4. That is how this happens. And since I can't leave the top blank, I put a 1 there to hold its position. So number 11 is doing to a power. So we're going to go ahead and multiply those exponents. So I get 3 times negative 5. The y is going to be 4 times negative 5. The z is 1 times negative 5. The w is negative 6 times negative 5. See if we can fit this in here. I might have to do some moving down. So if I go ahead and do the multiplication of the exponents, I get x to the negative 15, y to the negative 20, z to the negative 5, w, since I have a negative times a negative, I get a positive 30. Now right away I can see that x, y, and z all have negative exponents. I'm not allowed to have that. But my w is positive, so we're going to actually leave the w in the numerator. We're going to move the x to the denominator. We're going to move the y to the denominator. And we're going to move the z to the denominator. So this ends up being the final answer in that situation. Okay, number 12. So it's a lot like number 11. We have to a power. We just have some on the top, some on the bottom, so in the numerator and the denominator, so we're just going to have to do it in both. So I'm going to leave it in the fraction to start. So I have a to the 3 times negative 6. b, now remember the b is to the first, so it's 1 times negative 6. In the denominator I have x to the 3rd times negative 6. And I have w, which is to the 3rd times negative 6. So I'm going to go ahead and draw a line through here and kind of separate this out. So I'm going to go ahead and do the multiplication of the exponents. 3 times negative 6 is negative 18. 1 times negative 6 is negative 6. X, 3 times negative 6 is negative 18. 3 times negative 6 is negative 18. Now all of these have negative exponents. Since they're all negative, they're going to have to go to its opposite. So those on the numerator are going to go to the denominator, and likewise those in the denominator are going to move up to the numerator. So the final answer is going to end up being x to the 18, w to the 18, over a to the 18, b to the 6th. Go ahead and box that so I can see my final answer. Now 12, everybody was taken to the negative 6 power, so both the numerator and the denominator multiplied by negative 6. In 13 they have two different numbers that their power is 2, so we're going to go ahead and do those separately. So my numerator is going to be x to the 3 times 4, y to the 8 times 4. My denominator is going to be x to the 4 times 5, y to the 6 times 5. So I get 3 times 4 is 12, 8 times 4 is 32, 4 times 5 is 20, 6 times 5 is 30. Now the difference between 13 and 12 also is that in 12 the variables were different on top and bottom. Here they're the same. Since I'm dividing and I have the same bases, I actually need to subtract my exponents. So I'm going to slide right here. So I'm going to do top minus the bottom. So I get 12 minus 20. And for y, I get 32 minus 30. 12 minus 20 is negative 8. 32 minus 30 is 2. Now, I'm almost there. The only issue I see here is I have a negative exponent, which is not okay. So I'm going to move the x to the negative 8 to the denominator, so it'll become a positive. Since y squared is already a positive, it's going to stay in the numerator. There's your final answer. So you definitely want to make sure you have as few variables as possible. If you can combine, as we did here, the x's together, the y's together, you want to make sure you do that. Okay, we're going to do one story problem, and then we're going to go ahead and take a short break before we move into roots. So the story problem says, what will the population be in 2020? So we have a formula. F of t equals a times 1 plus r to the t. A is the initial amount, r is the rate of the increase, t is the time. So we have three numbers here, 100, 0.3, and 20. We're going to plug them into the appropriate places, and then we're going to go ahead and solve. So A, so I'm going to rewrite the formula here. Okay, A is 100, R is 0.3, and T is 20. So if you think back to order of operations, the first thing we're going to have to do in here is we're going to go ahead and put together the parenthesis. So we get 100, 1 plus 0.3 is 1.3. Now if I look at this, parentheses or grouping symbols are done, but I do have an exponent. So I'm going to go ahead and do the exponent. So I'm going to do this section. So definitely I'm going to use my calculator for that. I have no idea what 1.3 to the 20 is. So 1.3 to the 20 power, huge number, so we're going to put down it's approximately 190.0496. Now we'll go ahead and do the last step. We only have multiplication left, so we'll go ahead and do that. So I'm going to multiply these, so times 100. So in 2020, our population should be 19,004. Almost to 5, but not quite. That's pretty good growth in 20 years. You go from 100 people to 19,000 people. Okay, so take a short break, get a drink and stuff, and we'll be back in a moment with roots.